Now we're next going to look at how we can go from the equation of a line to a sketch of that line using our knowledge of the standard form of a straight line. We saw last time that the standard form was y equals mx plus c, where m is the gradient of the line and c is the y-intercept where it cuts the y-axis. So for instance, if we have this equation here, y equals 5x plus 3, by comparing with our standard form, we can see that m is 5 and c is, hopefully you see, is 3. So then we can sketch that by just drawing our axis here. We know that c is 3, so we know it cuts at y equals 3. It has a positive gradient of 5. So we go along 1 and up 5, so it's a pretty steep line. Oops, sorry, that should be going through 3. Poor sketch, but you get the idea. Let's try another one. This one here is 2y equals 3x plus 4. Now, before we can compare that with the standard form, we must have it in the form y equals, not 2y equals. So we have to divide everything by 2. When you divide by 2 on the left, you have to divide every term by 2 on the right to keep the equation balanced. So we get y divided by 2 equals 3 over 2x plus 4. So we've divided the 3 by 2 and the 4 by 2. Then, comparing with our standard form, which we can now do because we've got it in standard form here, y equals mx plus c. We see that m is 3 over 2 and c, this should say, sorry, c is 2. C is 2. So again, we could sketch that up here. We'll do it. So we've got our axes. We cut at 2. And our gradient this time is much shallower. We go along 1. We go up 1.5. 1.5. So we're getting a shallower straight line through C, through y equals 2. Let's look at another one here, another example. This time we've got 2y plus 4x equals 7, so we've got some more algebra to do, some more manipulating with the equation before we've got it in standard form. First thing we take the 4x over to the other side and it becomes minus 4x. It's plus, or if you like to think, I take minus 4x off both sides. So we get 2y equals minus 4x plus 7. Then we can divide by 2 and we get y equals minus 2x plus 7 over 2. Then we're able finally to compare with our standard form. Our gradient is minus 2, that's the number in front of the x, and our y-intercept is 7 over 2. So this time we've got, if this is our axes, this time we're cutting at minus 2. No, sorry, the gradient is, we're cutting at 3.5, say here, 3.5, so you'd mark that in as 3.5. And the gradient's minus 2, so this time it's negative. We're going along 1 and down 2, along 1 and down 2, so it's of this form broadly, a negative gradient. So that's how we get from the equation to the sketch. The main issue is we'll have to rearrange any equation we're given into the standard form, y equals mx plus c. Then we can deduce m and c. Now, we also have to know how to do the opposite, to go from the graph to the equation. So for instance, we've got this graph here, and we have to get the equation. Well, it's the same idea, but what we do, we work in reverse. What we've got to find, we write down our standard form, y equals mx plus c. So we've got to find m and c. Well, in this one here, c we can just read off. It's minus 1. C equals minus 1. That's where we're cutting the y-axis, and then the gradient we can just count the boxes. So we've got 1, 2, 3, 3 along to this point, and then 1, 2, 3, 5 up. So the gradient is 5 over 3. So the equation using our standard form is just going to be y equals 5 over 3x mx minus 1 for the y-intercept. If we want then, I mean that's correct as it stands, but we could multiply through by 3 and we could have it in the form 3y equals 5x, because when we multiply 5 over 3 by 3, the 3's cancel out, minus 3. So that's the equation of this one. Let's have a look at one more. This one here, again, to get the equation we start y equals mx plus c. C we just read off. In this case it's cutting at y equals, here's 0, so 1, 2, 3, 1, 2, 3, 4. Now 0 must be down here because it's telling us this is 5. 1, 2, 3, 4, 5. So actually, well, it doesn't look like it. The axes, there's a mistake in this. This is V and T. 1, 2, 3, 4. This is actually 4 here, so we'll change this. And this is 1, 2, 3, 4. So it's 4 and 4 actually. So our standard form is y equals mx plus c, and c, where it cuts the y-axis, is 4. 1, 2, 3, 4. And the gradient, well, this time we're going down 4 and along 4. So it's minus 4 over 4. M equals minus 4 over 4 equals minus 1. So the equation is y equals minus 1x, which we just write as minus x, plus 4. And in fact, it's not y and x in this case, it's v and t. So the equation should really be written as v for y equals minus t for x minus 1t plus 4. So that's how we go from graph to equation. We deduce the m and the c and then just sub them in the standard form.